Once I did consult with I said, I know that right there. I'm just thinking, every shot. I think you can't shoot this. I didn't already have to shoot it fast. Yeah. Really? I don't know why I did. You're still shooting finger shot, probably. Very sure it's like a stranger. Maybe it's the throw people in me. Well, it doesn't take you. Are you saying? But you need to go down and sort it on the side. Oh. Oops. All right, let's begin. I'll start with problems 15 and 16 from, good, Mike, camera, file, action. Looks good. The two questions from chapter 7. Here we have 100 stocks, so you have 10,000 total cells. You have 9,900 total covariance terms. And sometimes they ask you how many unique covariance terms. Well, there's 2 of every one, right? So you just split the other side of the, you got the 100 variance terms. And then on either side of the diagonal, you have basically a mirror image. So it's really only 4950. So actually, if we went through all that trouble of doing covariance and all that. There's actually functions in Excel that will do covariance for you directly. And they'll give you that covariance matrix that we created, except they only give you half it. You're supposed to know that the other half's the same thing. So anyway, yeah. All right, then the standard deviation, here's our equation. So we take the average variance, so the standard deviation here was 30%, so the average variance would be the 30% squared, divided by n, plus 1 minus 1 over n, times the average correlation times the products of the standard deviations. Right? And for this one, I get 19.26%. But if you can just keep this equation in your mind, you can answer a large number of questions. Like, for example, we're going to go to the next question. It's going to ask, what happens if the covariance goes to 0? Well, think about it. Just look into this equation. What happens if, first of all, I got to identify where is the covariance in this thing? I'm sorry, the correlation. If the correlation goes to 0, what happens? Well, that's this 0.4, isn't it? So if this 0.4, oops, if this where am I? Interesting. Well, it's right here. Oh, interesting. Okay, if this 0.4 goes to 0, then this entire term goes to 0. Okay, and then what happens as n gets very large? Okay, so 30% squared is 0.09, isn't it? That's not a real large number, 0.09. What happens if you divide 0.09 by 1,000,000? That's essentially 0, isn't it? So you can see that if you could find a correlation between stocks of 0, you can actually eliminate all risk from the portfolio, can't you? So the limits of diversification with a correlation of 0 is 0. You can take it to 0, can't you? Okay, but on the other hand, since correlations are not 0, how low can we go? So what's the limits of diversification for these specified parameters? And that would be so again, go right into the equation, set n to a monster number, million, and you can see that this term essentially goes to 0. Put 1,000,000 in here, 1 minus 1 over 1,000,000, which is really 1. So this is all you have left, it's right here. So if I take the square root of the average covariance, I get the minimum. I didn't have to remember that, right? Do you see that? I can remember, okay, average covariance, that's the, I got to take the square. You don't have to remember that. Just go into the equation and see it. Okay, so how far away are we from fully diversified? Well, with 50 stocks, you have another, 0.28% to go, don't you? So that's not bad, is it? So you as a personal investor, if you had 50 stocks in your portfolio, you would be just about as well off as a huge mutual fund as far as diversification, wouldn't you? Right. Then the next problem, I think it said to go from 2 to 10, didn't it? I went from 1 to 10, I don't know why. Go from 1 to 10, and you have a correlation. First of all, 0.3, then we did it again for a correlation of 0. And you draw the, so for part B, you have the, for part B, you have the standard deviation of the portfolio approaching that minimum variance, and that minimum variance is 21.91%, but not touching it. And then on the other hand, for part C, the covariance actually being 0 because the correlation is 0, this number has to approach 0. It doesn't get there very fast, does it? So at 50 stocks, you're still pretty far away from your asymptotic limit, aren't you? Okay, so the minimum variance is 4.8%. The minimum standard deviation is 21.91%, and then that's in part C, of course. The minimum standard deviation is 0. So we could take that all the way to 0 if we had a 0 correlation between stocks. Do we have that? No, you don't. No such thing. All right, that's all we have here. Let's see, do we have any questions on that? Let's go to Team Aru here and see how we're doing. Okay. So that chapter 7 can be summarized in that single equation, can it? One equation. All right. Let's move on then, if we could. Let's move on to the next topic, which is managing debt. And if I were attached to this book at the umbilical cord still, again, you know, I think I mentioned this is where I learned my finance. I had the first version of this book. Okay, and if you get into about chapters 14 and on, an overview of corporate financing. Okay, that'd be interesting to do. How corporations issue securities. That's 15. Then you get into payout policy, all the good stuff. Does debt matter? Does it really matter how much you borrow? And then it keeps going. How much should a corporation borrow? And you got a theoretical approach to this. Yeah, we could have done it. However, I found what I thought was a little better approach. And there's a PDF file which is available. I made it available to you on Canvas. And it says financial strategy, planning and managing the corporate leverage position. Okay. So I don't know, I honestly don't remember why I came across this article, but I came across it. And I said, you know, this fits better into what I do in class than would be those chapters in the text. So I did this instead. I've been doing this for years. Okay. But look at the first question they ask here. Okay, over the past few years, there's been a significant increase in attention devoted in the financial management literature to the financial aspects of the development of corporate strategy. While a concern dimension has always been the present, the recent surge of interest is striking. An apparent motivating factor has been the growing popularity of value creation tests as guides to the selection of strategic alternatives. And that, what they're talking about here is how much debt should I use? Okay, so one thought is, let's pick the amount of debt that we believe maximizes value. Okay, right, and then you got all that. But if we go back to my document, I summarize this, I think, pretty nicely, I hope. So how much should a company borrow? And in my opinion, the answer should be the same as you would give if you were asked how much you should borrow. And you should not borrow any more than you can afford to repay, period. So why did we have the crisis, the mortgage crisis in 2008? Because people were getting into houses they could not begin to afford. Okay? So as long as you stay at a debt level that I can afford to pay. Okay. I mean, now obviously, we know all things are not certain. Yeah, so we have no certainty, but common sense would dictate that you should not borrow more than you have a very strong chance of being able to repay. And I say here the same holds for the company. A responsible company would do this. A measure of the company's ability to service, and you'll see the word debt service. What is debt service? Make payments toward. How many kinds of payments do you have? Interest and principal, right? Okay, most the companies we're dealing with here borrow via bonds. So how do bonds work? Interest, 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 mature, principal and interest. Interest, interest. So you only pay principal one time, right? When the bond matures. And what do they do when it matures? Well, if they're maintaining a certain debt ratio, debt to asset ratio, they reissue it. So they replace the bond that just matured with another one of the same amount, and debt interest. So their big concern then is basically interest, right? So a measure of the company's ability to service, make payments toward its debt is the ratio of its operating income compared to its debt service payment requirements. So if you view an income statement, what do you see? You see, once you come down to EBIT, what comes out next? Interest. So EBIT is the first claim on the, interest is the first claim on the company's operating income. Okay? So we'll be working with something called the coverage ratio, and we're going to simplify this greatly. The coverage ratio is the earnings before taxes and fixed charges divided by fixed charges. Okay, we can complicate this to no end. We could, for example, throw in leases. So fixed charges include interest and other required before tax payments, such as leases. Okay, but we will not do that. We're going to keep it simple. Let's say simpler. Simple is a bad word. For simplicity, from this point forward, assume that interest is the only fixed charge. Okay, so what we have, instead of EBT fixed charge, we have the coverage ratio becomes the same as what you had in accounting 202, the times interest earned ratio, or EBIT divided by interest. Where EBIT is the earnings before interest and taxes. So if you expand this, you see that the times interest earned has three parts to it. So it's EBIT over interest, but if you break it up into its component parts, it's actually EBIT over assets times assets to debt times debt divided by interest. So you can see this assets and this assets and this assets, they cancel each other. This debt and this debt will cancel each other, and you'll just get EBIT to interest. So this is just an expansion of the basic coverage ratio equation. Okay, if you rearrange this and solve this for EBIT to assets, you get times interest earned times interest to debt times debt to assets. Okay, we'll be back on this very soon. Let's go right now. EBIT over assets. All right, if I asked you and you were taking a 201 exam, one of the questions was, how do we measure ROA? If you're taking it, or 202, I think it is, 202 exam, the correct answer would be net income divided by assets. Return on equity, net income divided by equity. So return on is normally expressed as net income, right? But it can be expressed as a before tax income. So in other words, what we'll be doing, and a little explanation here, in order to have after-tax income, obviously a company must first generate before-tax income. When associated with the times interest earned ratio, which is before tax, expressing ROA on a before-tax basis is more useful. Okay, so for this unit, for this course, right, only, we'll be defining ROA as EBIT over assets. So this is the only place we'll see this, and I've got a feeling it's the only place you'll see it the whole time you're here. Okay. So if you've been so proud of yourself for remembering ROA as net income over assets, well, this is not the time to be proud, because we're going to change it. Okay, so we're going to express it on a before tax basis. We could actually do this on a cash flow basis. We could say cash flow to assets, but we're going to do it EBIT to assets. Okay, so then if we come back to this equation, EBIT over assets times interest earned times interest to debt times debt to assets. All right, this we've worked with before, and we've also worked with this one. Let's do this one first. What is debt to assets? What did we call that just in the last assignment we had? Or 2 assignments ago, I guess when we were doing when we were doing the free cash flows and the Oh, we haven't done free cash flow. I'm sorry, that's wrong. We did the float equity, we did the APV, we did the NPV. What did we do with debt to assets? What do we call that? That was our L, wasn't it? Leverage. That was the capital L. So we've done that. Okay. What is interest over debt? So you pay $10 of interest on $100 of debt. What does that tell you? Your interest rate must have been 10%, right? So this is nothing other than the interest rate. Okay. So your ROA, EBIT to assets, is equal to the times interest earned ratio times the interest rate times the leverage ratio. So let's come down. Okay. So here's ROA, EBIT to assets times now, and so on and so on. Okay, and then it's interest rate on debt equals capital R, and I took this right from that article. They use capital R, I'm going to use capital R, is the interest divided by the debt, and its leverage ratio, L, is debt to assets. Thus, we can express ROA as times interest earned times R times L. Okay, and if you solve this for TIE times interest earned, you get ROA divided by R plus L. Okay. Now there's a couple of things that we can do with this, and we're going to do both. And one would be, what's the critical TIE? What's a number we could focus on for TIE? How about if I told you a company's times interest earned is 6? Do you have any issues with that company? Absolutely not. They're earning enough to pay their interest 6 times, aren't they? Okay. So in other words, their operating income could drop to 1/6 of what it currently is, and they'll be able to pay their interest. That's a safe company. Okay. How about one with 2? Still not bad, but not as safe, right? So if their revenues drops to half of what they are, they can't pay it, or less than that. Okay, the big one is 1. Because if your coverage ratio is not 1, you are technically insolvent, and somebody could call in your debt. Could lead to bankruptcy, Chapter 7, Chapter 11 procedures. Okay, so we're going to focus somewhat on 1, and we're also going to look at a whole series of coverage ratios. All right, and if I give you a company's leverage ratio, okay, we're not looking for it, we know it, it's a given, then we're going to call that, we're going to put a star, meaning that it's a given number. Is that okay? So I tell you that a company has 10 million in debt and 100 million assets, you're going to tell me the leverage ratio is 10%. That's your capital L. It's a given. Okay, and then also the R. If you know the interest rate for the company, then we're going to put a star by it. If it's given, it has a star by it. So therefore, the ratio of 1 divided by R, the product of R times L, is a constant. So we're going to say times interest earned is equal to the ROA times this K, where K is 1 over R times L. All right, and you know what? This will make way more sense if we use some numbers. So let's do some numbers. Okay, let's open up an Excel file. And let's see, can I get a new one here somehow? All right. Now I'd like you to do in your new file, we're just going to get the information for the example where we can see it in Excel rather than going back and forth. So let's try something a little different. This is what I do most of the time when like say I'm working on an exam, and rather than having the Word file here and the Excel file here, I want to do the calculation, see if it's a good question. I'll just put the question into Excel, and rather, if you just put it in Excel, it all fits on one row, doesn't it? If I took something from the Word document and put it here, it'd spread it out till it's in one row. Okay, so what you do is you go to Insert, and you choose, have you done text box before? I bet we have. I'll choose a text box, and I'll just draw it here. And it doesn't matter what size you make it, you can resize it very easily. It's just like a picture. So I'll put it in a text box right here. Okay. I'll go back to my Word document. And I got an example coming up here. Here it is. So let's say right here, let's start from right here. So the EHO company has 30 million of 9% interest rate debt and 100 million of assets. Okay. So let's just take that. So it has 9% interest, 100 million in assets. I think that's all we can get out of here for now. We'll get some other things in a minute. Okay, let's just try that. So anyway, this is something you can do. So I'll copy that and I'll drop it into my text box so that it's got a nice format to it. And let's go here. Ah, perfect. We'll fill in a little more here in a minute. Let's just leave it here. Okay, so what do we know so far? We know assets, and that's going to be 100. Let's just use 100. We know that debt is 30. We're given the interest rate, that's the capital R, of 9%. Let's see, what else do we have here? And then we have, we can do the leverage ratio, L, and that would be 30 divided by 100. So I can just get that very quickly. Okay. And then this small k, let's do our small k. So we won't cap this, we'll just say small k, it's a constant. And that equals 1 divided by, equals 1 divided by the product of L star and R star. So it's going to be the product of 9% times 0.3. Yes, no, never let Excel correct you. Tell the nanny no. Okay, and here you go. There we go. Fix it yourself. That's my K. All right, now let me show you what that does for you. Okay, let's come back to this very fine article. See that? See where I got that? Right from here. Okay. What we're missing so far is not all coverage ratios are equal. If I say your coverage ratio is 1 for 2 companies, have I equal confidence on, am I equally confident that either one would pay their debt service? They both have coverage ratios of 1. Well, no, because you have to know the probability of earning that ROA. Okay, so if you have, so take this company, for example. Well, you can see the probability to the left here. So this cross-hatched area, this is fixed charges. So here's the mean, and this area right over here, that's the probability that they won't cover once. Okay, now what if you have a company with a different mean and standard deviation? It would look like this. And now look what happens to the probability that it won't cover. It's quite higher, isn't it? So you have to introduce probability into this, otherwise you can't treat all companies the same that have a coverage ratio of 1. Right? So anyway, the next graph is a good one. Does this look familiar? There you go. All right, let's go to the next graph. All right, here we are. So what this tells me is that if I want a coverage ratio of 1, then the required ROA will be 1 over this K. If I want a coverage ratio of 2, the required ROA will be 2 divided by the same constant. Okay, and 3, 4, 5, and so on. Now, do you see what happens here? This company has a expected coverage ratio right around 3, doesn't it? Expects to cover 3 times. So there's a 50% chance that they'll cover less than 3 times, right? Okay, once you specify a coverage ratio higher than that, such as 4 or 5, then the probability of that coverage ratio being less than that number is over 50%, isn't it? So it's the area under the curve you're working with, right? So let's go back and let's create some a graph. We won't create the graph, but let's do some work along these lines. Oops, that's on me. Let's close this. Oh, I don't have close up. All right. Okay. All right, so we have the K. And let's do a little table here. I'll just use capital CR. Come on, man. What you doing? Coverage ratio. Let's go out here about, let's say 1, 2, 3. Let's stop here just for a moment. I'll show you what. Okay. And let's go back to the Word document, and we'll get the rest of the information we'll be needing. Okay, so for this company, a coverage ratio of 1 means what? EBIT over interest comes out to be 1. So how do you get a ratio of 1? Well, the numerator, denominator have to be the same, don't they? So EBIT equals interest. So for my example company, you can see that they have 30%, let's go back here. They have 9% debt and 30 million of debt. So therefore, to cover once, EBIT has to be 2.7. Does that make sense? So if your interest equals your EBIT, you're covering once, right? So EBIT has to be 2.7 to cover once. Right? For a coverage ratio of 1, all right. So EHO must earn an ROA of 2.7 in order to cover its interest charge 1 time. Okay, now let's enter the probability in here. Let's get the rest of this. EHO expects a 3%, 10.3 and 3%. Okay, let's copy that. And let's drop it into here. Okay, then if you want, you can tighten up this thing, give you a little more room to operate, whatever you want to do. All right, so let's, you know what, let me insert a couple rows here, probably a little tighter than I need to be. So let's insert a few rows here. Okay, so let's do expected ROA. Okay, and we know that's 10.3%. And let's do the standard deviation of ROA. Oh, went past my size. Okay, I better open this up a little bit. All right, and that would be 3%. All right. Now we have just about everything we need to know. Okay, well, let's do one more thing here. Let's do our expected coverage ratio. Okay, you do that for me. How many times does this company expect to cover? Give me a few seconds to do that.
We're supposed to work, so this is not getting long.
I gotta do Linux. Yeah, Yeah, life is so good. Just found out my office computer has a black screen. So that's always nice to know. Okay, what do we get? How many times are we covering an average? How many times? Anyone? What does it take to cover once? 2.7%, right? What's their expected ROA? 10.3, is it not? So if 2.7 covers once, what does 10.3 cover? That's not supposed to be the meaning of life. Okay, so we're going to have 10.3 divided by, since we don't have that 2.7 here, let's create it very quickly. We're going to say it's the 9% debt times the 30 million in debt. Well, that'll be the 2.7, won't it? And divided by the assets. Okay, so all this together right here, B9, B8 divided by 100 is 2.7 divided by 100, which is 2.7%. So 10.3% divided by 2.7%, you get 3.814. Oops, that didn't work very well. Okay. All right, so let's do this. Instead of going to 4, let's do our next coverage ratio of 3.8148. Then we'll go to 4. And then we'll go to 5. I don't know, how long do you want to go? Let's go to 6. All right. So this was our coverage ratio. And let's do our required ROA. What kind of an ROA do we need to cover once? Well, we know the answer here, don't we? What's the answer here? I know that answer. It's equal to what? 2.7%. We've done that. Okay, but we're going to do it a little differently. Okay, if we go back to this PDF file, it says that to cover once, the ROA must be 1 divided by this K. Okay, so we calculated K. And so let's do that. We're going to say equals, what's up here? Divided by K, and make sure you lock K, F4, Command T, type in a $sign before the B and the 11, or for me at least. So I get F4. And what should this say? It better say 2.7%, shouldn't it? And it does. So if you want to make these percents so you can follow a little nicer. Okay. There's the required ROA. All right, and then let's work with the probability of ROA being less than 2.7%. So what's the probability that this company will not cover one time? That's equivalent to the probability that this company's ROA will be 2.7, or will be less than 2.7%, right? It's saying the same thing. Okay. So let's set it up with a z-score. Okay. Okay, and what are we be testing? We're going to test ROA, are we not? So the z-score would equal the ROA, whatever you're testing. So we're going to be testing 2.7%. ROA. And how do you do z-scores? You take some number you're testing and compare it to the mean, don't you? So minus the expected value. And then you divide it by the standard deviation of the ROA. Goodness, that got big, didn't it? Okay. So how am I going to do this? Let's do this. Let's bring this over here so it gets out of the way. Still not out of the way. Whatever. There we go. Okay. So let's do the z-score up here. Okay, let's understand something about this normal distribution. I don't know if you remember any of this from statistics or whatever. Okay. This, if you say that a number has a normal distribution, okay, then obviously it has to have some characteristics. It has to have a mean and a standard deviation. Okay, I cannot work with whatever this number is. In this case, it's EBIT. It might be dollars. It might be an inventory of some number of sales of this item. Well, the sales were 400,000 a year with a standard deviation of 200,000. Well, I can't put that into this graph. Okay, so what you want to know on this graph is if we're going to do, like, for example, coverage ratio 1, I want to know this distance from here to here. That's what I have to tell the statistical function. What's this distance? And you have to tell it in terms of standard, how many standard deviations it is. How many standard deviations is it from here to here? Okay, that's what we just did. Okay, so right here, our expected ROA was 10.3, wasn't it? Okay, we want to go all the way back to 2.7. Okay, so I can't express that number in percentages. I have to express it in standard deviations. So it's 10.3 back to 2.7, and then one standard deviation is what? 3. So I take that difference and divide it by 3. Now I have the number of standard deviations. So I have to know this distance in terms of how many standard deviations is it. And that's what we did with the z-test. Okay, and so let's do it. Equals. Take the number you're testing. So how far is that from the mean? First of all, in percentages. So minus, and lock the mean. F4, Command T. Okay, so that's the distance. That's the distance in percent. If I want to convert that distance from percent to standard deviations, I have to divide it by 1 standard deviation. So divide it by 1 standard deviation, and that's 3%. And you would want to lock that also. Isn't that nice? What on earth is Excel thinking? Okay, so to cover once, this distance is 2.53 standard deviations. Okay, now we can find the probability. There's 2 ways to do it. Let's start out with the hard way. Okay, 2 ways to do it. And let's see, let's get our score again. 2.53, okay. Now the importance here is the sign. Okay, let's go back here for a moment. If you get a negative z-score, it means going left from the mean. If you get a positive z-score, that means going to the right from the mean. So we're getting a negative score, so we're going to go back this way, 2.53 standard deviation. That's all the negative and positive mean. Is it to the right or is it to the left? If it's a negative number, it's to the left. And just out of common sense, if I get a negative z-score, my probability has to be less than 50%, doesn't it? Right? Because you're starting here and you're going this way. It will be something less than 50% for sure. All right? So 2.53. Now also in the Word document, if you go toward the end, probably almost to the end. Excuse me. No. There it is. Looks like it's page 7. I have what's called a standard normal distribution table with the area in the left tail. So notice, if I am 0.0 standard deviations to the left of the mean, which means what? I'm on the mean. Then the area to the left is 50%, isn't it? Half the table. Okay, so let's come down and see what's left in the tail once you go 2.53 standard deviations to the left. So I come down here and I find 2, 5, 0, 1, 2, 3. So 0057. So this is less than 1%, isn't it? Okay, so let's go back to Excel. And that was 0.0057. No, you never do that, right? Why? Okay, we do this. Whenever you work with something with a normal distribution in Excel, if you can just remember the first 4 letters, N-O-R-M, norm. I always think of Cheers, right? That was the mailman in Cheers. You ever stay up late and watch Cheers? Old Cheers reruns? Never mind. So equals norm. And the 2 we want to use in this class, you can see you got quite a few choices here. The ones you want to use, there's something called norm S dist. So where'd you go? Norm, well, I can't even find it. I'll just type it. Norm S dist. So normal distribution. And you'll notice the input to that is what? You give it a z-score, it'll return to you a percentage, a probability. So give it a z-score, and where's the z-score? Well, it's right above it, isn't it? So now I'm just going to click on the negative 253. Okay. And I get, so the table's a little bit off for some reason. Oh, I guess, okay. I looked at the 253. Now you notice here? That's one of the problems with the table. It's not 253, is it? It's 253333. You just don't have that in the table. So anyway, percentage-wise, so what's the probability of this company not covering one time? It's 0.56%. Very low, isn't it? Okay. All right. Let's see if we can apply 12 grams of common sense. If it takes 2.7% ROA to cover once, what will it take to cover twice? Double that, precisely. I don't know why. I've asked that before, and people, let's see, I get an equation, I don't know. Yeah, it's got to be double. Sure it does. Okay, so, but hopefully we're in luck here. Let's try it. Let's hover over these 3 here. All right, and let's flow across to 2. And I think this is just being a butthead. Let's see if we can take some decimals out of it. There we go. So 1.63. So there is a 5.4% chance that the what am I talking about? There's a 5.12% chance that the ROA will be 5.4% or less. And we continue to 3. And look what's happening. Okay, now the z-score is 0.73. You're already up to a 23% chance that this company will have an ROA of less than 8.1%. All right, can you tell me what will be here? Before I even do it, that's why I stopped. I could have copied this all the way across. I did not do that for a purpose. Okay, what will this one be?
The expected.
Yeah, so let's do them one at a time. This will be the expected, no doubt about it. What will this one be? Do we get it or not? What is it going to be? 0. She's sleeping on me. I knew it. Knew it all the way. Yep, it'll be 0. Okay, who wants to do the next one for me? What'll I get here? Yes. All right. You're just quiet. People know what's going on. This is too easy. All right. That's so good to hear. Wonderfully. Okay, but now what's the big change now? What happens when I go to cover 4 times? Okay, I'm no longer going to get a negative z-score, am I? So here's where the transition occurs. We go past the mean, and from this point on, we will see nothing but positive z-scores. And, you know, since we only went to 6, I'm not sure, I shouldn't go much more than about 70% maybe. What are we gonna get? Oh, I lied. It goes up to, oh yeah, it goes up to 2, yep. Excuse me. So all I know from this is that there's a 98% probability that this company's EBIT will be less than 16.2%, right? Or that they will cover less than 6 times. Okay, but what's the one you're concerned about? The big concern is this one. What's the probability that you'll be unable to cover? You can't pay your interest. And it's quite small for this company, isn't it? All right. Now, any paper written in finance has to have, if it's going to be accepted at a reasonably prestigious journal, has to have 3 components. It has to have a concept. It has to have a concept and some equations to verify the concept. Then it has to have an empirical test of it. In other words, does this really happen? Okay, and this article passed all 3. So let's come down if we could. I'm going to come down here a little bit. Let me show you something. Here we go. All right. Bond ratings. It's so funny. We have, I don't know who it is. I'm on a committee that we have to evaluate research proposals. And if we think it's a good proposal, then we'll grant the faculty member like $7,500 grant to work on it in the summer. So I'm reading all these research proposals, right? And what's one of them? How do you predict bond ratings? Or actually the title is something to the effect of predicting bond ratings from accounting variables, okay? And I thought, oh, this is interesting. Let's see what this person has on it. Because I've probably read 4 or 5 of these in the past, and it turns out that one variable tells all but the whole story, the coverage ratio. So if you've got a strong coverage ratio, you're going to get a high bond rating. If you've got a lousy coverage ratio, you're going to get a very poor bond rating. Okay, so look at this. AAA. It used to be, I think we saw AAAs fairly commonly. Now, I don't remember, it was either IBM or some other very strong company issued a bond and got a AA. So those are hard to get. And why might they be hard to get? Well, look what's happened in the past. Okay. Average number of standard deviations between mean ROA and ROA necessary to meet fixed charges. So, go back up to this graph again. Okay. So if you have a AAA rated bond, the distance from this mean out to where you cover once is 6.6 standard deviations. Okay, now do you want to, let's just apply this to what we know. Let's sneak into here, just pick a cell, I don't care. And let's say equals norm S dist. And let's go negative 6.6. So what's the probability of a AAA rated bond not covered? Okay, let's see if we get a percent. Oh my. Oh my. Okay, it doesn't fit. Let's go a little bit. Okay. And then if we go back to that article, let's see what they said. Oh, okay, that makes sense, doesn't it? Less than 0.0001? How about way less? So actually, these first three categories are all safe, aren't they? And then you go to BAA. It's still not bad, but anyone remember what's the significance of BAA? What happens when you fall below BAA? And if you look at it, a B single A still isn't bad, it doesn't seem bad, does it? It's less than 1%. Okay, but if you fall below BAA, you're no longer what's called investment grade. So investment grade bonds fit into retirement portfolios, they fit into pension fund portfolios, they fit into all these portfolios that that are commonly managed. Well, if you're less than BAA, you don't get into those. So you never want to be below BAA. But a AAA rated bond, 6.6 standard deviations. And I think maybe that's why we're not seeing so many. I don't know why, but I mean, this, I didn't want to, break that person's paper apart, but this tells it all, just about all of it, whatever your coverage ratio is. In fact, I do something for one of my classes that we have to do we have to do the WACC for a company. Okay, we pick a company that isn't publicly traded. How do I find the cost of its debt? Well, you can read it from you can read it from their 10K, but they don't publish the 10K, if they're not publicly traded. What do? There's something called synthetic bond ratings. And so you can find a chart that tells you the spread between the risk-free and a AAA bond is this much. And then if you plug in the company's coverage ratio into that, you can say, well, their bond rating should have been about this, therefore their cost of debt should be about this. We call it synthetic bond ratings. It's all based on the coverage ratio, 100% based on the coverage ratio. And this person had an equation. Bond rating equals alpha plus beta times coverage ratio plus, had about 14 things trying to predict bond rating with. And it's going to come down to the first one. I could be wrong. This might be something different. But this is it. This is the whole story of bond ratings, your coverage ratio. All right, so we have next to no probability that, another one here. The C rated, look at C rated. Okay, there's about, you're getting up there toward 50% chance that they won't pay. They'll be unable to cover, right? Now, I had a colleague who used to buy D-rated bonds. You see those here? No, you don't. What's a D-rated bond? In default, D, default. They're already in default. They're not going to be repaid. So why would he buy a D-rated bond? Because you can get a $1,000 bond for $20. So what it is, it's an alternative to going to Turtle Lake, is kind of what it amounts to. Yeah, I'm going to buy this $1,000 bond for $20. So if by the time the company liquidates and you come out of there with 40, you doubled your money. You see, bonds are paid in liquidation. You have your secured bonds are paid first, then your unsecured debt, and so on. So you're up there in the priority. I mean, the shareholder. Shareholder's down here, right? But the bonds are paid first. So he's willing to try it. Well, good luck. He used to hit a couple of them, but I think he missed on as many as he hit. Well, way more. All right, so anyway, that's the practicality of this. So let's go back. Where were we? All right, so any questions on how to calculate the probability that a given company will be unable to service its debt once, pay its interest once? So I have in your assignment, I start out with this is the first question, okay? And I'm not going to get into it today because I won't finish it. But the next question is, let's start here, 0.56%, okay? So this company with 30 million in debt against 100 million in assets, has a 0.56% chance of not covering. What if they were willing to live with 1% chance of not covering? How much debt could they maintain? What kind of a leverage ratio could they use? Well, I think you can see that it would be greater than 30 million, wouldn't it? Okay, so what we're going to do on Thursday is we are going to reverse this process. Rather than knowing the leverage ratio, knowing the cost of debt, we are going to flip this and ask how much debt can this company manage if they're willing to live with a certain probability of not covering. And that's what we'll do next. All right, so that's all I have. If you have any questions, I'd be very happy to answer them. I haven't checked out Neverland for a while. Hope they're all right there. Uh-oh, this is deep doo-doo. Oh no. You know, this frickin' Teams just didn't do what I wanted to do. Oh no. You can't tell me this. I joined this one. Oh no, don't tell me. I'll be sad. That seems all right. Okay. Yeah, we're all right. I was thinking I gave a perfect lecture to section 1 all over again. This thing mixes these up on me every time. I thought it was pretty careful, so I think we're all right. All right, that's all I have, unless you have a question about something.
There's a question on Teams.
Oh, there is? Oh no, I closed it. All right, well, let's go back to that then. I'll see if I can answer it. I don't know why I shut this thing down because all right, let me join again. I'm sorry, thank you. Can you show the formula for the z-score? Oh, I sure can. And that's actually right here.